But an oxidation occurs when an ion loses electrons, and a reduction occurs when an atom or ion gains electrons. So remember, Leo, the lion, says grr. Loss of electrons is oxidation, gain of electrons is reduction. Okay? They always occur together. If one substance is oxidized because it's losing electrons, it's giving its electrons to somebody else who's going to be reduced. We've always got to have one with the other. Okay, so in a single displacement reaction, we are doing redox, right? There's a oxidation reduction reaction occurring. Okay, ions oxidize, and ions reduce. Here we have a reaction where we put a piece of copper metal, and I think we did this one in, for most of you in the honors chem. We put a solution of silver nitrate in, and what happens is the copper displaces the silver. We're left with silver metal plating out on the copper, and we get copper nitrate solution, which happens to be blue. The copper plus 2 ions are blue. If I write the net ionic, this is what I get. Okay? Don't forget that when we have displacement reactions, or sometimes called signal replacement reactions, we need to make the judgment of whether or not the reaction is going to occur based on how reactive it is. Okay, so remember we have this activity series, and we're actually going to use standard potentials, and I'll show you that table. You should have it in your reference pack that I gave you. But the opposite reaction of what we just did, which was copper plus the copper nitrate plus silver, it's not a two-way reaction. It does not occur. And that's because if I look at my activity series, the copper is right here, my silver is right here. So the copper the silver has to be more reactive than the copper for it to replace it, and it's not, so it won't.